In this video, we're going to review some matrix and vector algebra. I think there'll be some new stuff, maybe for some of you who've already done linear algebra, not much in terms of the algebra, but maybe a little bit new in terms of how you implement it in Matlab. All right, so we want to talk about the algebra. And a good place to start is with an example. And so the kind of problems we would like to solve with the algebra of matrices and vectors, the simplest example is to solve two equations in two unknowns. So we'll do an example, and we have two equations, 2x1 plus 4x2 equals to 2. And the second equation, which I'll write in red, is 4x1 plus 11x2 is equal to 1. All right, so one thing that we've done that's a little bit different maybe than you're used to is that instead of using x and y, we used x subscript 1 for what is usually called x and x subscript 2 for what is usually called y. And the reason we do that is that very quickly we're going to progress to problems where we have very many variables, hundreds of thousands of variables, and then the alphabet is just not long enough. We don't have enough letters. All right, so for the solution of this problem, it can be obtained by plotting the two lines. So, right, the first equation is the equation of a line, and so we could imagine plotting it. And we can plot the second line, the red one, right, and look for the point of intersection. Now, I have a ruler here, and I do have graph paper, and I try to do it by hand when I was trying to prepare this lecture, and my graph was always a mess. And so what I decided we should do is do the graph in Matlab, right? Because part of what we're trying to do is also learn Matlab. So I've done this over here. Oh, let me get rid of these at first to introduce what I'm trying to do. So I wrote this little wrapper function called EasyPlot with capital EZ that uses MATLAB's EasyPlot function. So EasyPlot for Matlab is very nice. It very quickly plots a function. So you pass in a function handle, f, and it will make a plot of it. The only problem for the purpose of this lecture is that the line is kind of thin, and the color is light blue, and the font is very small on my screen, so that it's easy. It's not easy. I mean, it's hard to see the graph, even though it's an easy plot. It's easy to make, but not easy to see. So I've put this wrapper around it, and then I reset the line width and the line color. And I set the font size to be bigger. So all we have to do if we want to do this graph over here is to define these functions. And we will define the two, I guess these are equations, but if I bring back, so what we're going to do is rewrite the first one this way. L1 of x1, y1, no, not x1, y1, x1, x2, sorry, x2 is going to be defined as 2x1 plus 4x2 minus 2. And so this equation, which defines a line, corresponds to L1 of x1, x2 is equal to 0. So this is the equation of the line. And for the other one, we have L2 of x1, x2 is defined as 4x1 plus 11x2 minus 1. And then this line will be L2 of x1, x2 equal to 0. So I'm going to define these two functions over here using inline functions in Matlab. So L1 is going to be an inline function of x1 and x2. And we define it as 2 times x1 plus 4 times x2 minus 2. Let me put some spaces so we can see. And then L2 is 4 times x1 plus 11 times x2 minus 1. And then we can, to find the solution, we can make a plot. So H1 is equal to EasyPlot L1, and the color, the little C here, that gets set to the line color, and I will make the first one to be black, like the way I wrote the equation. And then to plot the other one on top, I do hold on, and I plot H2, easy plot, L2, and this one I'll plot it in red. And I'll put the grid so we can see where the intersection is. All right, let's try it out. And so we have this graph. Let me stretch it a little bit. And you can see where the two lines intersect out here, right? And we can zoom in to see where the intersection point is. And it looks like it's at 3 minus 1, right? So the solution should be 3 minus 1. Let's verify that. If I put in 3, I have 2 times 3 is 6, minus 4 is 2, so that works. So 4 times 3 is 12, minus 11 is 1, and this one works also. Now, once we know the solution, it's easy to check. If we didn't know the solution, we can solve it using what's called Gaussian elimination or row reduction. And so I'm going to do this right now just so to remind you how it's done. So we start off with 2x1 plus 4x2 equals 2. And the second equation, 4x1 plus 11x2 equals to 1. And what I do is this number here is called the pivot, and what I will do is I will take the first equation, divide by 2, and then subtract 4 times what I have from the second equation. So if I number my two equations here, equation 1 and equation 2, I do equation 2 minus 4 times equation 1 divided by the pivot, which is 2. And I will replace the second equation by this. So what I end up with after I do this, the first equation is unchanged, 2x1 plus 4x2 equals 2, but the second equation is 4x1 minus 4x1 is 0, so I have no more x1s, and 4 divided by 2 is 2, so I have 8x2. I subtract that from 11, so I have 11 minus 8 is 3, so I have 3x2 is equal to, and on the right hand side I have 1 minus 2 times 2 is 4, so 1 minus 4 is minus 3. And now I can solve for x2. So now already I have x2 is equal to minus 1. And from there, I do what's called back substitution, and I go back to the equation above this one, and I substitute in what x2 is, and I can solve for x1. So back substitution. Yields 2x1 plus 4 times minus 1 is equal to 2, which means that I have 2x1 minus 4 equals 2, or 2x1 is equal to 2 plus 4, or x1 is equal to 6 divided by 2 is equal to 3. So x1 is equal to 3, and putting these together, I get the solution over here, which is at the point 3 minus 1, like I have on the display. Now here I did all the algebra, the tedious algebra. It was a 2 by 2 is not too bad by hand, but of course we'd like to get Matlab to do the solution for us. And the way that to see how Matlab will do it, it's useful to write down these equations in terms of vectors, and then later on in terms of matrices. So we can take the first two equations, we group them together, and we take the coefficient of x1 is 2, 4, and we call that a vector. And this multiplies x1. And then to this we add plus x2 times, what does x2 multiply? Well, it multiplies 4, 11. 4, 11. And then that is equal to, on the right hand side, 2, 1. So these here, these are called vectors. So this is a vector. Vectors. And they are vectors that lie in the plane, and they have 2 coordinates. So they have, they define a direction and a length, as we'll see later. But for now, we can try to plot these vectors and see what we need. So to get a solution, what we want to do is we want to take this first vector, 2, 4, and stretch it by multiplying by x1. And then to that add the second vector, 4, 11, after stretching it by x2, and jiggering x1 and x2 in such a way that the sum of these 2 vectors scaled by x1 and x2 produces the right-hand side, the vector 2, 1. So that's another way of viewing these equations. Here we think of it as the intersection of 2 lines. In this case, we view it as the as vector addition. So we're going to add 2 vectors that are scaled in such a way to get a third vector. Okay, so let's do this. So I've also written in this little script something called vector plot, and it used Matlab's quiver function. So the vectors are written, the vector plot function takes in the vector v, which is a component, so it would be, for example, 2, 4 for the vector, would be 2 component, and it takes in a position, so it tells you, we need to know where to plot it in the plane. So vectors don't have a location, they are just a direction and a length, but when we plot them to see graphically what's going on, it's the vector addition is, the rule is you plot the arrow and you do tip to tail kind of addition that you might remember from algebra class. And so we have to move one vector to the tail of the other. So first of all, let's plot our vectors. So I'm going to create some vectors. This will be figure 1. And then I will do figure 2. And H3 is equal to vector plot. And I want to plot V1. So I guess I can rewrite this in this way. X1 times V1. The little underscore means that this is a vector, plus X2 times V2 is equal to the vector B. So V1 is 2, 4. V2 is 4, 11. And B is 2, 1. So I'm going to create these vectors in Matlab. So before I plot, let me define the vectors. So V1, and I want it to be a column vector. So in Matlab, we do row vectors. So we separate the elements with a comma. If we want to make a column vector, in other words, if we want to stack 2 on top of 4, then we separate them with a semicolon. 4. So this would be the column vector 2, 4 because there's a semicolon separating the 2 and the 4. And now V2 is 4, 11, and B is 2, 1. Alright, and now I can make my plots. H3 is equal to vec plot V1, and I'm going to plot it at 0, 0. So 0, 0. And the first vector, I'll plot it in black. And then the second vector, whoops, I shall plot it in red, but also its tail will start at 0. And then for the third vector, B, I will plot it in blue. All right. Now, if the idea of vector addition is right, what we would like to have is that 3 times v1 minus v2 produces blue. So produces the b vector. So let's see if that works. H6, and I put the keyboard in between so we can have a bit of suspense. I will plot 3 times v1b, sorry, not b, v1, and I'm going to plot it at the tip of the first vector. So that is v1. And if I plot it again, times v1 and then I can plot actually I don't need all these handles. Let me get rid of these, they're messy. Okay, so let's run it again. Alright, so this is the original picture of the intersection of two lines, and over here I have the picture in which I have the 3 lines. So this vector, the long red one, is the vector 4, 11. So right, the tip is at coordinate x2 is equal to 11, and coordinate x1 is at 4. And then the black one is the vector 2, 4. So the tip is at 4, and is at, sorry, the x2 is at 4, and the x1 is at 2. So it's not at scale. Maybe I should add an axis equals. Let me do that. Let me start over. Hold on, grid on, axis equal. So it looks nicer. db quit clear all ex. There we go, that's more to scale. Okay, so now if the algebra is correct, if I add 3 times the black vector, 1, 2, 3, I'll end up somewhere over here, and then I would subtract the red one and I would end up back down here. So let's see if it works. db continue, and indeed it does. So let me make it big so you can see. So this is the original v1, this is 2 times v1, this is 3 times v1, and then from that I subtract 1 times v2, and that brings us back down to where this blue vector is, which is the right hand side of the b vector. Alright, so these are 2 different ways of thinking about 2 equations in 2 unknowns. Okay, so how do we solve it in Matlab? So the next step in Matlab is to join these 2 vectors, v1 and v2, in a matrix. So we construct a matrix A, and to remind, oh, I'll get rid of this. So we're going to take v1 and v2 and construct a matrix A. So I've been using the little underscores to define vectors. So A is equal to the vector v1 as its first column, and the second column is the vector v2. I'll put it in red. So I'm going to try to encourage you to think of vectors, matrices, sorry, instead of a 2D array of numbers, to think of it as a collection of vectors. So sometimes it's more convenient to think of A as a collection, a two-dimensional table of numbers. Sometimes it's more useful to think of A as a collection of row vectors. But for now, we're going to think of A as a collection of columns. So A is going to be what's called a 2 by 2 matrix, right? Because it has 2 columns, 2 columns. And since V has 2 rows, it's a 2 by 2 matrix. So 2 rows, A is a 2 by 2 matrix. The first number is the number of rows, and the second one is the number of columns. So if we put those together, A becomes 2, 4, 4, 11. And now this the matrix multiplication, or the equation, the system of equation, becomes 2, 4, 4, 11 times the unknowns x1, x2 is equal to the right hand side 2, 1, or A times the vector x is equal to B, where x here, x is the vector with x1 and x2. So the way we think of matrix vector multiply, we think of the first component here of x multiplies the first column, and the second component multiplies the second column. That's the picture we had that I just deleted. Let me rerun it again. So this picture here is the one we have, where we think of this x1 multiplying the first column and this one multiplying the second column, such that we get the right hand side. All right, so how do we enter matrices in Matlab? Let's do it. So there's different ways. I'm going to show you a bunch of different ways right now. So we can define A to be equal to V1 comma V2. Remember, the comma separates the columns, and the semicolon separates the rows. So V1 is already a column vector, so I can create A by just sticking the two vectors side by each other, like that. Another possibility, so method 1. Another possibility is the following, method 2. A is equal to, and now I could just put in the numbers directly. 2, 4, semicolon, 4, 11. That's the second option. And I guess I'll give them different names. No, what I'll do is I will not put the semicolon. So then when we run the code, the matrices will show up and they should all be the same. That was method 2. Method 3. A is equal to 2, 4, 4, 11. We could just enter them directly like that. So in this case, I entered the two rows separated by the semicolon. You can put the square brackets or not, leave them out, it doesn't matter. So here it's two rows, the row 2, 4 and the row 4, 11. Here it's two columns, the column 2, 4 and the column 4, 11. I think those are the main ones, main ways in which. We can also just assign, I guess, method 4, which is kind of tedious, but we can do the following. A is equal to zeros 2 by 2, and then we say A of 1, 1 is equal to 2. A of 1, 2 is equal to 4. A of 2, 1 is equal to 4, and A of 2, 2 is equal to 11. And the last one, I'll leave it out so we can see the matrices. Alright, so let's run it, see what we get. EX. Alright, so we should have a bunch of A's, always the same, right? So, right, 2, 4, 4, 11, 2, 4. They all gave the same thing in the end. So the three methods gave the same thing. Now, how do we find the solution? Well, Matlab has a very easy way to find the solution. We can solve it in the following way. X, what we want to get the solution, what we want x such that a times x is equal to b. And the metaphor is that we can divide both sides by a. And what we get is a divided into a times x is equal to a divided into b, which means that x is equal to a divided into b. And so this backslash, which is the kind of is analogous to the b divided by a, or b over a if this was a scalar, is the metaphor that Matlab uses for the solution. And so we'll have x is equal to a backslash b. And let's try it out. And so we have the solution 3 minus 1 as x. All right, so this completes this short introduction to solving linear systems with Matlab. We'll do more later.